I bet he can put it.
If you remember what day.
All right, guys, this is a complex fraction. And in order to do this complex fraction, the first thing we have to remember is the difference between a factor and a term. What is a factor? Remember, I've put comments on some of your tests about this. What's a factor? Well, what's a term?
Two sets of numbers.
What's happening?
It's part of the multiplication equation.
Now, that's the factor. When things are being multiplied, it's a factor. When they're being added, they're terms. Parentheses are going to be a very useful tool here. Okay? So we want to work with them as much as we can. And remember that this fraction bar is just a symbol of inclusion. So we're going to do everything in the numerator first and then into the denominator. So in order to do this problem in the numerator, we have to have a common denominator. What would it be? BC. All right, so if we are going to change this B to BC, what have we done?
3C.
3C, that's right. And what are we going to have over here?
B squared.
B squared, okay? Over 1 plus C, or over 1C. All right, so now then, we would have 3C plus B squared over BC, right? Everybody agree? And that's all over 1 over C. What else besides being a symbol of inclusion does that fraction bar mean? Yes. So you're going to take the 3C plus B squared over BC divided by 1 over C. This is a term. 3C is a term. B squared is a term. Remember that. So you're going to have 3C plus B squared, two terms, over BC times C over 1. BC, both are factors. You can cancel factors. You can never, ever, ever cancel terms. So we can cancel these out, and we will end up with an outcome of 3C plus B squared over B. You see it?
Don't put parentheses on the 3C plus B squared.
Yes, you certainly can.
Are you gonna do it with
Yes, because it's terms, and so we don't want to start crossing them off, right?
In the beginning, with the BC on the denominator, is it like B squared because there's already a C in the denominator?
No, there was a B here and a C there.
Yeah, but then on the, like when you go down,
We don't need another B, we already have one.
okay, so if it's in the denominator, it doesn't have to be in the numerator? Yes.
I don't think I understand your question.
Like,
See, we already had a B, so to get the BC, we multiply this by C, and we do have to multiply the numerator by C.
okay, but since, oh, okay.
And over here, we already have the C, so we multiply this by B, so you have to multiply that by B, and that's where 100 got the B squared.
Okay. Wait, is that only in this kind of problem? Or in
Any
other
kind of
fractions?
problem, any fraction.
Okay.
So when you say you can't cancel terms, we can cancel the factors, could you cancel the C out of the 3C, but you couldn't cancel the whole 3C?
Because the 3C is like it's caught in a deep web with that 3, and it would take some kind of major problem to separate it. And as long as you got that plus sign in there, you're not going to get away from
So you can't cancel anything in,
it. With a plus sign, no. Okay? Rachel? If we were to bring that up, it would have to be this way. B to the negative 1 times 3C plus B squared. Okay? Because remember, if it's in the denominator, you move it up, you have to change the sign. All right, let's look at another one, please. All right, now this one says, oh, this is a joy. Y to the negative 1 plus z y to the negative 2 all over y to the negative 1 z to the 4th. Okay? So the first thing we're going to have to do is get rid of those negative signs. So this is going to be 1 over y plus z over y squared. And that's over z to the 4th over y. Where did I lose you, Michael?
The divided by is over c to the 4th.
Down here,
No, the very bottom.
here, but see, the z to the 4th was positive, and the y was a negative 1, so we would have to move it down here.
Or this.
I'll go on, and if you can't follow me, let me know, Mike, okay? Yes,
If you bring the negative y down to the other one and make it.
no, because negative 1, y to the negative 1 is a term, there's a plus sign in it, okay? So now then, we have to have a common denominator here, and what's it gonna be?
Y squared.
Yes, it's going to be y squared, okay? So what did you multiply this y by to get y squared, Joe?
Y.
So that's what's in the numerator, because 1 times y is y. This one already has y squared, so we don't have to worry about that.
This is what learning feels like.
Yes, that's right. Z to the 4th over y. So now then, we're going to have what? What's the numerator going to say?
YZ over y squared.
Y plus z
Oh.
over y squared, yes. And that's going to be over z to the 4th over y. Okay, now what do we do? Zach, what are we going to do next?
So it's gonna be a y plus z over y squared times y to the negative, no, times y over z to the
Yes.
4th. Yeah.
And this will take care of one of those. So we end up with y plus z over y z to the 4th.
Can you not cross out the z because of the z?
No, because this z is a term. There's that plus sign. And the plus sign makes it a term. Never cancel terms. You cancel factors to your heart's delight, but never cancel terms.
So when you're multiplying, you don't need one of the numbers.
No, that's right. That's a good point. See, if you're adding where you're dealing with terms, you have to have a common denominator. When you're multiplying, who cares? Like I can't, that's right. Caleb, you had a question? Which one? Here?
Yeah.
Okay, we had a y squared and we had a y. So the common denominator would be y squared. You don't want a y to the 3rd, that just makes it messy. Okay? All right, you guys try this problem.
It's,